All right, IM3, we're back. Hopefully for number 2 and number 4, you got these answers to match these guys right here. Number 2, you should have got 3 log base 6 of x plus 9 log base 6 of y. And for number 4, you should have gotten log base 2 of x squared over z squared times y to the 6th. All right. Now we're going to start off by doing number 5, and I want to kind of think about my goals as I'm walking through this. So my first goal is to isolate the logarithm to solve this problem. So if I look at number 5, I have this multiplier out here that I want to get rid of. I'm going to divide everything by 6, both sides of the equation by 6, to get the logarithm by itself. So I end up with log base 6 of a minus 6 equals negative 1. This is a point that I want to make sure you guys realize. You might see the minus sign and think quotient rule, but that minus sign is inside the argument. It has nothing to do with quotient rule. All we're going to do from this point on is convert to exponential form. So I have 6 to the negative 1 equals a minus 6. A minus 6, I'm going to solve for a. First, convert this negative exponent into a fraction. And now add 6 to both sides. So I end up with a equals 6 1/6. All right, next one we're going to do is a little bit different. If you notice, number 6 has a logarithm on both sides of the equation. The one thing that is nice about the logarithm on both sides of the equation is if they have the same base, then you can simply set the arguments equal to each other. So 4n squared plus 4n is equal to 45 plus 3n squared. So when they have the same base, I can set the arguments equal to each other. And now I just need to solve for n. Start by getting it's quadratic, so we're going to try and get it set equal to 0. Minus 3n squared from both sides. Left with n squared plus 4n equals 45. Subtract 45 from both sides. N squared plus 4n minus 45 equals 0. Now factor the quadratic. Plus 9 minus 5. So I have two solutions for this one. N equals negative 9 and n equals 5. You will want to think about whether these answers work or not, and they're not extraneous solutions. Remember, you cannot have a negative base or a negative argument, and the bases cannot equal 1. As far as that goes, these should be fine. They both work when they get plugged back in up there. It will never end up giving me a negative argument.